In this video, I'm going to be explaining our code for the Halloween lights project. On the front panel, we have 4 Boolean arrays. Those arrays allow us to control the patterns of the LEDs. Each number corresponds to a number in the case structure. Then we have our RGB LED. It uses 4 arrays. The values of those arrays range from 0 to 1. We chose specific values to control the colors of the LEDs. Then we have 2 controllers. The first controller controls the speed of the DC motor. The second controller controls the rotation of the servo motor. It ranges from 1000 to 2000 because we wanted to limit the rotation of the servo motor. This value shows the values of the pulse width modulation and converts it to degrees. Then we have our phase timing. Our phase timing has numbers that range in time, where each range corresponds to a specific special event in the music. Then we have 2 diagrams that show data from our chosen music. And then we have a 32 by 1 array with specific thresholds for each section of the music. And then this array shows the current pattern that's currently being displayed. On to the block diagram. We first open up a connection between LabVIEW and Arduino by using OpenLinks resource. The serial port allows us to connect the COM number that we're currently using on our computer. So first we have a while loop for the RGB LED, which was used for a traffic light in the project. This while loop turns on at the beginning of the show and stops once the third case structure is run through. We use set duty cycle of N channels where we have pins 3, 5, and 6, which are all pulse width modulation pins connected to the pulse width modulation channels. And then we accept values of duty cycle, which range from 0 to 1. We have specific case structures, which are controlled by the index values of the iteration, but incremented by 1. So the first one is going to be number 1, and it accepts a value of values of 0 to 1 in the array, and it has a specific timing to hold for a specific amount of time. And case number 2 also has an array and 3 as well. And the loop will stop once the iteration reaches 4, or if the stop button for the code is pressed. This while loop was for the DC motor control, which was used for a ceiling fan and a cart in the project. We first used a digital write function of N channels and accepted values of 10 and 12 for the do channels. Those are the pins that were used. And this accepts values of Boolean. Therefore, we had a controller that was sent to a true or false case structure where we're able to control the spinning direction of the motor, either counterclockwise or clockwise. And then we have the set duty cycle, which again accepts values from 0 to 1. However, our controller ranges from 0 to 100. So in order to scale that, we had to divide those values by 100 and send it to the set duty cycle. And our pin 11 is a pulse width modulation pin, and it was used for the set duty cycle function. And then at the end, we just made sure to turn off all the pins. This while loop was used for the servo motor of the dancing ghost in the project. First, we open up a connection of the servo motor function, and pin number 2 was used for this servo motor. Then we have the right servo motor function, which accepts pulse width modulation values that is controlled by the user, which range from 450 to 2450 usually, but in our case it was from 1000 to 2000. And what this does is that it converts the pulse width modulation values to angles in degrees, and it displays it on the screen. And then we close out the connection of the servo motor function, and after that we make sure that all the pins are off after the code has stopped running. Here we have a while loop for the master stop, which allows us to stop the entire code by one single button. And we also have an OR function, which can also stop the code if the song is finished playing. This while loop is used for our LED light patterns. First, we'll start off by setting all our pins off, and it outputs an array of falses, which is named all false, which will later be used as a local variable to turn off all the lights all the pins at the end of the code. And it also outputs an array of all the pins from 12 to 13, which will also later be used to turn off all the pins at the end of the code. So starting off, we use the sound cluster that was provided by the professor, and what this function does, it's called, so first we use the sound cluster that was provided by the professor, and it basically reads the audio file, input it, and it runs into the loop. Then we have the sub VI, which is called getSample, and it takes in the audio file and plays the music. Here we use unbundle by name to get the Boolean value of end of file ? And basically if the song stops playing or if the button of stop is pressed, this loop will stop running. Here we used a music threshold array, and we used the index array function to take out specific sections of specific rows of the array from the local variable called number, which we'll explain later. And then the last sub VI that was used is called extract waveform data, and it outputs the data diagrams which were displayed on the front panel. And here we also used unbundle by name to get the current maximum of the song currently playing, and if that maximum is greater than the threshold, the local variable threshold from the array, then this gets inputted as true in the case structure. So here we use the elapsed time function to utilize the elapsed time along with the max min limit, and how this works is that the elapsed time gets asked if it's in range within the start and stop values that we chose, and if it is, then only one true Boolean value will be outputted and all the others will be false, and then we convert that to a number, and that number will be used to get into a case structure of different values. So for the first one, which is number 1, which is basically 2 to the 0, we set all the LEDs off. For the second one, we asked if the threshold was lower than the current maximum, and if it was, then we generated a random number and multiplied it by 9 and converted it to an integer. And we also had patterns of LEDs on the front panel, and this number was used to randomly pick out a column from the patterns. And if it was false, everything would be off. And then we did the same thing for number 4. We also used a random number generator. Same thing for number 8. For number 16, we did not use the true or false case structure, but we still used the random number generator. And for number 32, we had a specific Boolean of constants, and we sent it to the digital write-in channel. And if it was false, everything would be off. And for 64, what we did was we used a random number generator and multiplied it by 255, converted it to an integer, and converted the integer to a Boolean array, and sent that to the digital write function. And outside the loop, we made sure all the pins were off by using the local variables that we had made earlier.